Hello, I would like to talk to you about limits. The informal definition of limits is that they are a y value that the function intends to reach. It does not necessarily have to get there, it just has to be headed that way. So, how would you determine that y value? Well, the simplest way is to look at the function formula. So, let's look at our basic parabola f of x equals x squared. We know it reaches very many different y values, depending on what the input value of x is. For example, f of 2 equals 4. And when x equals 2, we could put it this way, the graph has an f of x value of 4. So notationally, we have the limit as x goes towards 2 of f of x is 4. Let me erase all of this. Okay. So, what if there's a problem? Let's look at g of x. Can you evaluate g of 2? Now you might have noticed that the bottom is 0, and you might have stopped at saying, well, that means it's undefined. Let me just write the fraction and put the 0 in the bottom. But what happens if we are also looking at the top and plugging 2 into the top? Then you should notice that you get 4 minus 12 plus 8, which is also 0. And when we get 0 over 0, anything can happen. So what I would like you to do is get your calculator out and look at what the graph of g of x looks like. If you graph g of x, you will see that it looks like x minus 4. However, you cannot plug in x equals 2 to that point. So there's actually a point that is not on your graph. It may not show if you look at your calculator graph, but it will definitely show if you look at your table for the graph. Now the graph intends to reach the y value of negative 2. It's just not allowed to have x equals 2. But since it intends to reach that, the limit does exist. So we would say the limit at x equals 2 does exist, and our notation looks like this. So let's look at a semi-realistic example. You and a friend are meeting at Ranks, which is centrally located between both of you. You live east of Ranks, and your friend lives west of Ranks. You both head from your homes. You will both meet at the same place. The limit exists. You both met at the same place. You intended to go to the same place, and you did. Coming from both sides, you both reach the same place. That is when a limit exists. For a specific value of x, the y value is the same from both the left and the right. There are potential problems. What if your graph looks like this? From the right, the y value from the right, the y value is 2. And from the left, it looks like the y value is 0.5. Well, those aren't the same. So to use an example, assume this time you and your friend agree to meet at Starbucks. If you go to the one on Mass Ave and your friend goes to the one on Bedford Street, you will not meet up. So if this graph represents you and your friend, you do not end up at the same place. Mathematically, the limit does not exist. This can actually happen. We handle the situation by looking specifically at the limit from the left and the limit from the right. And we have notation that is going to highlight that. So right here, if you notice, there is a little negative next to the 1. That implies we're coming from the values that are less than 1. And so this limit is 0.5. Whereas when we're going from the right, that is a little more than 1, so there's a little plus. In this case, we seem to be going towards 2. So the limit exists even if there is a hole. Let's give an example. Let's say there's a new calculus cookie shop in town and it bought out Baskin-Robbins. The calculus cookie shop wants a new building more conducive to calculus students, so they tear down the Baskin-Robbins building. You and your friend didn't know this happened and only realized it once you both arrived at the old Baskin-Robbins location. You arrived at the same spot, but Baskin-Robbins was not there. This was like our graph of g of x, which could not have x equals 2. The function intended to go to that place, just like you and your friend intended to go to Baskin-Robbins. And you did end up at the same place, even though the point was not there. So limits exist if you tend to go towards the same place, not if you actually have that value. Limits are about where the function is headed, not where the function arrives.